Hi everybody, this is Mrs. John and welcome to my class. This is for year 11 and it's a mechanics question based on energy, and I've had a request to work through the questions on conservation of mechanical energy, and this is question 5, and I'll read the question. So a child throws a 0.30 kilogram ball down to the ground as hard as she can to make it rise up into the air as high as she can. At the instant it leaves her hand, it is 1.2 meters above the ground and it's traveling downwards with a velocity of 11 meters a second. Now, there are two things you can do to a ball. If you're holding a ball and you simply drop it, the initial velocity it has is 0. But if you're actually moving your hand to make the ball bounce as high as it can, so it's got two forms of energy at the top while you're holding it. One, gravitational potential energy because of the height above the ground, and the other is it has kinetic energy if you're actually moving it. If you want it to bounce really high, you give it that initial speed at the top. So actually the ball has got two forms of energy at the top there. And so this question is considering those two forms of energy. So what do we have to do first? So this is what happens. So she drops the ball with an initial velocity as well as height, and it reaches the ground and it bounces above a height that you actually threw it from. So that is the concept. So calculate the kinetic energy of the ball the instant it leaves her hand. So kinetic energy is half mv squared. So kinetic energy is half times mass is 0.30 kilograms and it's 11 squared. And what you get is you put these numbers in your calculator and you're going to get 0.5, which is the same as half. So there's my calculator, times 0.30 times 11 squared, and I get 18.15 joules. So this is 18.15 joules of energy. Okay. And then what do we have to do? The next thing is calculate the gravitational potential energy the ball loses while it travels down. So anything that's falling is going to gain kinetic energy and lose gravitational potential energy. So the gravitational potential energy lost is mgh. So the gravitational potential energy lost, the mass is the same. G is 10, and over here the height is 1.2 meters. So you just go 0.30 times 10 times 1.2 and you get 3.6 joules. So it loses 3.6 joules of gravitational potential energy. The next is, what does this gravitational potential energy change to? So as it's falling down, this gravitational potential energy due to the height is being changed to kinetic energy. So what is the total kinetic energy? So it already has this much kinetic energy, and that also becomes kinetic energy. So your total kinetic energy is, you just add those two. So 18.15 plus 3.6. So you just put that in your calculator and you end up with 21.75. So it's 21.75 joules. Okay, so if you know the total kinetic energy, the last part is what is the speed with which it hits the ground. So your formula for kinetic energy is half mv squared. So your half mv squared is 21.75. So your half times 0.30 times v squared is 21.75. Half of 0.30 is 0.15 v squared is 21.75, or v squared is square root of 21.75 over 0.15. So divided by 0.15, get an answer, shift square root, and I get 12.04 as my answer. So it's 12 0.04 meters per second is what my calculator tells me, but all the numbers in the question are two significant figures, so I'm just going to leave my answer as 12 meters per second. I hope that made sense. Bye for now.